Hello guys, welcome back to Insa Electronics. So in this episode, we are going to see what will happen if you connect a neon bulb without the current limited resistor directly to AC mains. So here you can see the neon bulb and the current limiting resistor is bypassed using a piece of yellow wire. You can see that over here. The only difference here is that I'm using an isolation transformer at this moment. This isolation transformer is capped at 20 watts peak, so it cannot deliver anything above few milliamps of current. Now, this isolation transformer is required because otherwise if you connect it straight across AC mains, it's not that interesting, it's just boring because it's going to blow the fuse or trip the breaker. But with this setup we can actually see what is happening. So it's connected in a way that the right side meter, the fluke, measures the current flowing through the neon bulb. The left side meter, the Meco one, measures the voltage that is connected across the neon. So at some moment we will see the voltage will stay constant and it's going to pass a lot of current because neon bulbs has a tendency of being acting as a voltage stabilizer, kind of like a Zener diode, and that is one reason this is actually used in some vacuum tube devices, as a voltage stabilizer. So once we started, we will see what is exactly going to happen. And the isolation transformer, because it can limit the current to a max of 20 watt, it's going to prevent any explosion or any kind of blow up situation, things going out of control. And the primary of this isolation transformer is connected to the variable transformer right here. So this is a 1:1 transformer, so whatever goes in comes out at the secondary side. Only limitation is that the maximum power it can deliver is of up to 20 watts. So I'm going to start the variac right now and you will see the reading on the right, the current flowing through the neon bulb. On the left you will see the voltage, and as a precaution I'm using some plastic, a piece of plastic, just to keep the neon bulb inside. So if it decides to go bang, at least it will protect the glass from directly reaching my face. It is required because it's going to get really hot really fast. So let's start. I will update on the screen the power consumption. You can see it will start conducting once it reaches around 70 volts, you can see, and amps is showing 0 because it's not sensitive at that low current, and at around 70 volts, that is the striking voltage of a typical neon bulb, and you can see the bulb is lighting up and the exposure is not adjusted, so you will see a slight increase. Now almost 2.9 watts of power being consumed. You have witnessed it, almost 2.9 watts of power being dissipated with that small neon bulb. Without any current limiting resistor, there is nothing there to prevent the current being drawn from the source. And this is exactly why this will trip the breaker, because it's going to draw a lot of current in a very short time. And once again starting up, and you can see now I'm increasing the voltage, but it is staying constant at around 60 or 70 volts. The only difference is that the current is increasing because the neon bulb has stabilized, so the voltage is not going to change and it's going to pass a lot of current. You will see right now how much it is, because right now you can see the current is growing up and it almost dissipating 5.6 watts of heat. Did you see something right there? Wait, let me show you once again. Yeah, there it is, the magic smoke. At least this time it didn't bend over with a bang, thankfully. So it melted the plastic. It got so hot that it literally melted the plastic, because it's just this small thing dissipating over 5 watts of heat and it is untouchably hot. Now because these neons have a negative resistance property, once it started at a constant voltage, once it has stabilized at a constant voltage, then it no longer wants the voltage to be increased, and that is why the voltmeter was staying constant. But because of the lower negative resistance property, at that voltage it's going to pass a lot of current. So that is what is the reason why your breaker will trip or the fuse will blow, because right now the current is being limited by the see that 8.9 watts. It clocked at maximum of 8.9 watts. So if there was no isolation transformer, the breaker will immediately trip or the fuse will blow, because there is nothing there to limit the current that can flow through that negative resistance region. This time it got really hot that the solder literally came off from itself. It got desoldered on its own. So that is it for the moment, guys. If you want to see the same video without the current limiting transformer, the isolation transformer, just comment down below and I shall show you just by using the variac what will happen if you connect it straight across AC mains. Thank you.